Physicists say that the universe had its starting point in an event known as an enormous detonation roughly 13.7 billion years ago. This event marks the beginning of all that we know in the universe, a fantastic blast that led to all matter, energy, and existence itself. The theory of how things came to be has long been the prevailing scientific explanation for the origin and development of the universe, describing a moment when the universe rapidly expanded from a hot, dense state into the vast, grandiose cosmos we observe today. Yet, while this theory offers a framework for understanding the universe's early development, it leaves many questions unanswered. One of the most captivating questions is, what set off this giant blast? If the Big Bang was the beginning of all that exists, what caused it and why did it happen? These are questions that have fueled the curiosity of scientists for centuries, prompting serious review, discussion, and observation in the quest to understand the origins of our universe. Over time, researchers have continued to investigate both the science and history of the universe. The Big Bang has been the most dominant explanation for all that we see, from the distribution of galaxies to the cosmic microwave background radiation, the faint luminosity of the Big Bang itself. Countless studies have been conducted over the years, with thousands of researchers around the globe dedicating their careers to uncovering the secrets of the universe. The information gathered from these studies has consistently supported the theory of how things came to be as the leading model for the development of the universe. According to the theory, a mysterious force known as dark energy plays a critical role in the continued expansion of the universe. Dark energy, which is believed to be much more abundant than the energy found inside galaxies, acts as an anti-gravitational force, causing the universe to expand at an accelerating rate, opposing the forces that should theoretically slow everything down. The field of science has evolved significantly over time as technology advances, and we develop new tools for observation and experimentation. Our understanding of the universe continues to change, as things we once believed to be absolute facts have been proven to be incomplete or even completely wrong as new evidence emerges. A prominent figure in modern theoretical physics, Michio Kaku, has pointed out that even the theory of how things came to be, long considered the foundation of cosmology, is now facing challenges. Recently, observations made by the James Webb Space Telescope have sparked considerable debate among scientists. The telescope has detected 750 new galaxies that appear vastly different from what was generally expected based on previous models. These unexpected discoveries are driving researchers to reconsider established theories and delve deeper into the mysteries of the universe. As these revelations unfold, they hold the potential to reshape how we understand the universe. The James Webb Space Telescope, with its cutting-edge technology, is changing the way we view the cosmos. The discoveries it has made so far have pushed the boundaries of our knowledge, especially concerning the formation and evolution of galaxies. The telescope has captured images of many galaxies that defy previous assumptions, offering a new perspective on the universe's development. These discoveries are exciting not only because of what they reveal, but also because they challenge long-held beliefs about the Big Bang. For those eager to stay informed about the latest advances in space science and cosmology, the images and data from the James Webb Space Telescope offer a fascinating glimpse into the farthest reaches of space. The newly discovered galaxies, with their unexpected shapes and astonishing numbers, are prompting scientists to revisit their theories and explore new possibilities about the universe's origins. The James Webb Space Telescope has delivered some of the most breathtaking images of galaxies ever captured in a single shot. One can see many galaxies grouped together, their beauty and vastness awe-inspiring. For the average person, these images are a source of wonder and amazement, offering a brief look into the enormity of the universe. However, for scientists and researchers, these images are not just beautiful. They are also deeply puzzling. The galaxies captured by the telescope are strikingly different from what researchers had expected based on the Big Bang model. They appear smaller, more compact, and surprisingly older, raising questions about the accuracy of existing cosmological theories. These astonishing observations are causing waves of concern among established scientists, with some even using the term panic to describe their reactions to these new findings. The discrepancies between what was expected and what has been observed are prompting researchers to reconsider the fundamental assumptions of the Big Bang Theory. For decades, the Big Bang Theory has served as the primary explanation for the origins of the universe. According to this theory, around 13.7 billion years ago, the universe began as an extremely hot, dense point that rapidly expanded in what is commonly referred to as the Big Bang. This violent event set into motion the expansion of the universe, eventually leading to the formation of galaxies, stars, and planets, including our own. However, the new images captured by the James Webb Space Telescope challenge this long-accepted narrative. These images contradict the established story of the universe's birth and open the door to new possibilities about how the universe came to be. The galaxies revealed in these images appear to be too small, smooth, old, and diverse to fit within the framework of the Big Bang Theory of the universe's origin, suggesting that the true story of the universe's beginnings may be far more complex than previously thought. One of the most striking features of the galaxies observed by the James Webb Space Telescope is their size. These galaxies are several times smaller than those captured by the Hubble Space Telescope, which directly contradicts the predictions of the Big Bang Theory. According to this theory, as the universe expands, objects within it should appear larger as the distance between them increases. However, the galaxies observed by the James Webb Telescope are not behaving as expected. They are smaller and more compact, challenging the standard model of cosmic expansion. Moreover, the smoothness of these galaxies is an unexpected and puzzling aspect. The Big Bang Theory predicts that galaxies should exhibit a high degree of irregularity in their structures, with noticeable variations due to the chaotic processes of their formation and evolution. Instead, these new galaxies are remarkably smooth, with much less complexity than researchers would expect for galaxies of their age. This smoothness challenges the timeline of galaxy development and suggests that something about the standard model may need to be revised. At the very beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into a singularity, a point of unimaginable density. This singularity marks the starting point of everything, where the laws of physics, as we understand them, break down. In this state, matter and energy were so densely packed that their behavior becomes difficult to describe using conventional physics. The concept of the singularity is grounded in Albert Einstein's theory of general relativity, which explains how gravity works on massive objects. Within the singularity, the density of matter reached an infinitely high value, creating conditions that we cannot fully comprehend or replicate with our current understanding of science. The temperature was so extreme that it surpassed anything observable in the universe today. It is within this singularity that the seeds of the universe were planted, containing all the mass and energy required to create everything we see around us today. After the initial singularity, the universe began to expand and inflate, undergoing a rapid process that stretched the fabric of space itself. This expansion, known as inflation, occurred at an extraordinary rate, far faster than the speed of light. During this phase, the universe expanded dramatically, smoothing out any irregularities and laying the groundwork for the large-scale structures that would later form, such as galaxies and stars. Inflation played a crucial role in shaping the universe as we know it today. It helped to homogenize the distribution of matter and energy, ensuring that the universe would be relatively uniform on a large scale. As the universe continued to expand, the rate of expansion gradually slowed, allowing for the formation of more complex structures. Researchers have been able to observe the effects of this ongoing expansion through phenomena such as the redshift of light from distant galaxies, which shows how the universe continues to expand and evolve over time. During the universe's early expansion, all matter was compressed into an infinitesimally small volume, creating conditions that would have made it impossible for stable matter to exist in its normal form. As the universe expanded and cooled, however, these extreme conditions began to change, allowing particles like protons, neutrons, and electrons to form. These particles interacted with the surrounding light and energy, eventually leading to the formation of matter as we know it. This process, known as nucleosynthesis, took place during the first few moments after the Big Bang and played a vital role in the creation of the elements that make up our universe. Interestingly, while scientists expected to see chaotic and disturbed galaxies due to numerous collisions during this early period, the images captured by the James Webb Space Telescope tell a different story. Rather than seeing chaotic galaxies, the telescope has revealed galaxies that are unexpectedly smooth and regular. This challenges our current understanding of galaxy formation and calls into question whether the early universe was as tumultuous as once thought. These findings from the James Webb Space Telescope are reshaping our understanding of the universe's earliest phases. Instead of the chaotic, irregular galaxies we expected to see, the smooth, well-ordered galaxies captured by the telescope raise new questions about the conditions in the early universe. Were these galaxies really as orderly from the start, or did they evolve differently than previously thought? How did such smoothness come about in a universe that should have been far more chaotic and turbulent at its beginning? Scientists are also questioning the very structure of the universe in light of these new discoveries. The early stages of galaxy formation may not be as simple as the Big Bang theory suggests. If the galaxies we are observing were already in their current state of development, what does that tell us about the timeline of cosmic evolution? Did the universe take a different path than the one outlined by traditional models? Or are there aspects of galaxy formation we simply didn't understand until now? The discrepancies between the observations and the predictions of the Big Bang theory suggest that we might be on the verge of a major breakthrough in cosmology. The very foundations of how we understand the formation and expansion of the universe may need to be re-examined. Perhaps the smooth, early galaxies observed by the James Webb Telescope are not an anomaly but a clue, an indicator that something is amiss in our understanding of the universe's early history. One possibility is that these galaxies are simply older than we thought, pushing back the timeline for galaxy formation. According to the traditional Big Bang model, galaxies began forming relatively late in the universe's history, billions of years after the initial explosion. But the findings from the James Webb Telescope suggest that galaxies could have formed much earlier than we ever imagined, possibly challenging our understanding of the cosmic timeline. In fact, some researchers have speculated that these newly observed galaxies could represent some of the earliest structures in the universe, further complicating the narrative of the Big Bang model. The new data could also help to refine theories of cosmic inflation and the forces that led to the universe's expansion. If galaxies formed in a more structured and organized way than the Big Bang model predicts, there may be additional forces or interactions at play in the early universe, forces that we have yet to fully grasp. This is particularly true in the context of dark matter and dark energy, which remain some of the most mysterious aspects of modern cosmology. If the James Webb Telescope's findings are pointing to something new, it could help us unlock the secrets of dark matter and dark energy, two key components that seem to shape the universe's overall structure. Furthermore, these new insights could help explain some of the unresolved mysteries about galaxy formation. Traditional models of galaxy evolution suggest that galaxies grow through mergers and the accretion of matter over time. But what if these galaxies didn't need such chaotic processes to form? Could there be another mechanism at work? One that allowed galaxies to grow in a more systematic, orderly way? The ongoing analysis of the data from the James Webb Space Telescope will be crucial in addressing these questions. The telescope's ability to capture such detailed and distant images of the universe is allowing scientists to test existing models and form new hypotheses. These findings could lead to a major paradigm shift in our understanding of the cosmos, as the new discoveries challenge many of the long-held assumptions about the universe's formation and evolution. Ultimately, these revelations are pushing the boundaries of our understanding and presenting an exciting opportunity to rethink the cosmos in a new light. As scientists continue to analyze the data, we are likely to see significant advancements in our knowledge of the universe's origins. The next few years will be critical in reshaping the narrative of cosmology and may very well lead to groundbreaking theories that we have yet to even imagine. In the end, the discoveries made by the James Webb Space Telescope are not just changing our view of the past, but also opening up new possibilities for the future of cosmology. The telescope is giving us a glimpse of the universe as it was in its infancy, providing an unparalleled opportunity to study the formation and evolution of galaxies. By refining our understanding of how the universe came to be, we may finally begin to unravel the deepest mysteries of existence itself. The universe, it seems, is more complex and mysterious than we ever imagined, and the journey to understand it is just beginning.